I will go over 11.4, the cross product of two vectors in space. The cross product is used in many applications, for example in physics, engineering, and geometry involving finding a vector in space that is orthogonal to two given vectors. And the definition of the cross product of two vectors in space is very important and is necessary for us to remember. And the later example is how a product is used to time each other. And and you can see there's an example of A, B, C, D, and you just cross times A to AD and minus the times of B and C. And now let's go over example. Example 1, finding the cross product of given vectors, given u equals to I plus negative 2j plus k and v equals to 3I plus j minus 2k. Let's go over the solution for this question. U times v, let's put out a matrix of ijk in the first row, while 1, negative 2, and 1 in the second row, and 3, 1, negative 2 in the fourth row. And let's go over the rule shown in the early of the video. And at the end of this solving this equation, we get 4 minus 1 times I minus negative 2 minus 3 times j and 1 plus 6k. The final answer should be 3i plus 5j plus 7k. And in the form of theorem 11.7, the R-logic properties of the cross product is very important and is necessary for us to remember. Theorem 11.8, geometric properties of the cross product, and let u and v be non-zero vectors in space, and let theta be the angle between u and v. Those 4 rules are necessary for us to remember, and I will go over the proof for property 2. In fact, the proof for this property is not necessary for us to remember when we solve questions, but it's always good to have it in mind to know how we can get this property. Cross product u and v, we can actually find the unit vector that is orthogonal to both vectors, as shown in the example. First, we do the cross product of u times v, and we get the answer of negative 3i plus 2j plus 11k. And because the value of the vector u times v is root 134, and we can find the unit vector orthogonal to both u and v is negative 3 over root 134i plus 2 over root 134 and j plus 11 over root 134k. In physics, the cross product can also be used to measure torque, the moment m of a force F about a point P. If the point of application of the force is Q and the moment of F about P is given by m equals PQ times cross product F, the magnitude of moment m measured the tendency of the vector PQ to rotate counterclockwise about an axis directed on the vector m. To better understand the application of this, we go over this example question. A vertical force of 50 pounds is applied to the end of a 1-foot lever that is attached to an axle at point P, as shown in the figure. I find the moment of this force about the point P when the angle is 60 degrees. If you present the 50-pound force as F equals negative 50k, the lever as the vector PQ equals cosine 60j plus sine 60k, and it equals to 1/2 j plus root 3 over 2k. And the moment F about P is given by m equals to the vector PQ product of F. And the ijk in the first row, 0, 1/2, and root 3 over 2 in the second row, 0, 0, negative 50 in the third row. And by following the earlier procedure shown in the video, we can find the answer should be negative 25i. And the answer for this question is the magnitude of this moment is 25 foot-pounds. Trigo-Scatter point product right now shown in the picture, it is just like the cross product of two vectors. Instead of ijk in the first row, we change it to the vectors of the first equation. And from this property, we can also, by using this property, we can find the volume of a parallel pipe as with vector u, v, w as adjacent edges. Find the volume of the parallel pipe shown in the figure above, having u equals 3i minus 5j plus k, v equals 2j minus 2k, and w equals to 3i plus j plus k as adjacent edges. So we can put 3, -5, and 1 in the first row, 0, 2, -2 in the second row, 3, 1, 1 in the third row, and we get 3 times the matrix 2 minus 2, -2, 1, 1, minus -5 matrix with the matrix of 0, -2, 3, 1, and plus the matrix 0, 2, 3, 1. And the final answer for this question is 36. Thank you for watching this video, and I hope you have a better understanding of the cross product of two vectors in space through my video. Thank you and have a good day.